let's take a look at now some more challenging examples where we have to take situations or graphs or tables and convert them into equations of lines. So write an equation of a line with a slope of 3 that passes through the point 2, -4. So we have here a slope that's given to us of 3 and a point. So the easiest way to do this would be to use point slope form, because everything is given to us there. So with point slope form, we have y equals, and we've got some kind of number that goes there, and our slope here of m. And so let me erase that, and I will put here, let's say, a red box, and then we have some parentheses, and then x, and let's use a different color. Then we have another box. So the thing that goes into the red box is the slope. We can put a 3 there. And now we have to find what goes next to the y and what goes next to the x there. And so next to the y, we take the y coordinate of the point here, and we take the opposite of that. So the opposite of -4 is +4. So we write that over there. Then we look at the x coordinate, and the x coordinate is +2 there. And so we take the opposite of that and write it over here. So that is -2. So then our final equation for this line, and we write it in point slope form, is y + 4 times 3, or is equal to 3 times x - 2 in parentheses. And that's one way we could write the equation of the line. We could also write it in y = mx + b form from there, or well, even standard form, but those would take a lot more time to do. Okay, so the next one here, write an equation in standard form of the line that has a slope of 2/3 and passes through -2, 1. All right, so we want this in standard form, but we've got the slope and the point. So remember, with slope and point, the easiest way to do this is to write it in point slope form. Then we'll move things around and get it into the standard form that's required. So with point slope form, we have, let's write this out. So we have y, and then we've got something that goes next to the y is equal to, another box there, x, and then something that goes next to the x. And the x stuff is in parentheses there. So our slope of 2/3 goes there. That's where our slope goes. Then the y coordinate for the point is 1. The opposite of +1 is -1. The opposite of -2, which is our x coordinate, is +2, so we write that there. So this is y - 1 equals 2/3 x + 2. Now we need this in standard form for the final answer, so let's distribute here, and we get y - 1 equals 2/3 x plus 2/3 times 2 is 4/3. And now let's move this 1 over, add 1 to both sides. So this becomes y equals 2/3 x plus, so we have 4/3 plus 1, and we can switch that 1 into, so we've got a whole bunch of fractions here, so I can switch that to, say, 3/3 instead of the 1. Now we can add those. So this is 2/3 x plus 7/3. And now I can't have fractions for this standard form. So I multiply everything by a common denominator. In this case, it's 3 here for everything. So let's multiply both sides here by 3. And so this becomes here 3y equals, we'll distribute the 3 across, and this becomes 2x plus 7. And now let's we want the coefficient in front of the x to be positive. So let's move the 7 over. So we subtract 7, so we end up with 3y minus 7 equals 2x. And I want to move this y over to the other side. So I subtract 3y and subtract 3y. And so this becomes negative 7 equals 2x minus 3y. And so that is our final equation of the line in standard form. Wow. All right, let's keep moving. So write an equation of a line in slope-intercept form that passes through 3, -2, and 5, 6. So we want this in slope-intercept form. So slope-intercept form is y equals mx plus b. So this one will take quite a bit of work to get there. We have a slope that we would have to find, and we have some points here. So perhaps we can start with point slope form and then get it into this y equals mx plus b. Now, one of the ways I think of finding slope is I look at my x value and say to get from 3 to 5, I would have to add 2. So my x value is going up by 2. And then to get from -2 to 6, I would have to add 8. So my change in y values is positive 8, and my change in x is equal to positive 2. So this is a change in y over a change in x. Or also, this is exactly the same as our formula y2 minus y1 or x2 minus x1. So you can use that also. So this is equal to 4. So that is my slope here. And so let's go back to, so we have y equals mx plus b. We want this in slope-intercept form. I just thought of a faster way to do this is we can think of each of these numbers here as the x values are our input and the y values are output. So if you think of these as linear functions, that is our input and that is the output. And the same goes here. The 5 is an input and the 6 is an output. So let's start by saying y equals, we know the slope is 4, so y equals 4x plus b. And now you can pick any one of these points, but you can think of it as f of x is equal to 4x plus b. It's a linear function. So I'm going to pick the 5 and 6. So my input is 5 and my output is 6. And I can plug those into the function and then solve for b. So 6 is equal to 20 plus b, and I subtract 20 from both sides, so -14 is equal to b. So my final equation for the line in slope-intercept form is y equals 4x minus 14. All right, our last example now is another ACT type of question with multiple choice. So which of the following equations best fits the information in the table below? Now we don't know if this table represents a line or a quadratic or something else entirely. So let's take a look at how our x values change here. So from 4 to 8, I'm going to add 4 there. So that's my change in x. And then when I go from 8 to 12, I'm adding 4. So that is, it looks like a constant growth for the x's. And then for my y's here, I'm adding 1 to go from 4 to 5 and adding 1 to get from 5 to 6. So let's see, what is the rate of change going from these points here? So you can think of this as a point that's on the graph of this function or relation, and this as another point and this as another point. So how are things changing? We look at the slope between the first 2 points here. And so the change in y is 1 and the change in x is 4, and the same with between the second 2 points. The change in y is 1 and the change in x is 4. So my slope looks like it's constant between all of these points. It's worth checking every single one of these because there's no information here that tells us it's definitely a linear function, and there may not be choices. In this case, it's very clear that all of these given to us are lines. So the slope then here is 1/4 or 0.25, 1 over 4. And so that's very clearly like this choice here. Here the slope is 5, and here we've got negative 9.1, and here the slope is 2, and this is a horizontal line that goes through negative 9.5, so that's not going to work here. We need a line with a slope. These horizontal lines have slopes of 0, so that's not going to work. So that is the only choice. And notice how we didn't even need to use this information about the 3, and with the ACT test you have very limited time, so you have to use make very quick calls based on where you think things are going in terms of your question. So if you did have another choice here, like f equals, or f is your choice, so y equals 0.25x plus 4, how could you find out whether this one, f is right or d is right? So what you'd need to do is use that input-output method again. So you'd have y equals mx plus b, and write y equals 1/4 x plus b, and then b is something we don't know what it is. So what you could do is take one of these values here, so one of these points, 4, 4, and say 4 is our input and 4 is our output. So you plug that in for your output is 4 and your input is 4. Let's find out what b is. So this gives you 4 equals 1 plus b. Then I subtract 1 from both sides and I get 3 equals b. So this would be our answer and not this one, if you were given a choice where the slopes were the same. But in this case, it's very straightforward. That is the slope, and that is the answer for that. Okay, so that concludes our video, and I'll see you guys next time. Bye.